So this is question 7.51 from our chemistry book, page 250, and this is under the heading of solution stoichiometry. So the question asks us, how many milliliters of a 6.0 molar solution of hydrochloric acid would be needed to react exactly with 20 grams of pure sodium hydroxide. And they have given us the equation which can help us later on. So we have hydrochloric acid plus sodium hydroxide will give us sodium chlorine plus water. And we've seen this equation in our labs several times now. And so what we're going to do is we first need to recognize that our 6 molarity is really going to be, when we look at 6 molarity, what that's really referring to is that for every liter of solution, we have 6 moles of hydrochloric acid. And so the other thing that we are given is that we have 20 grams of pure sodium hydroxide. So well, we can't figure out the molarity of that sodium hydroxide yet because we don't have the moles, because molarity is moles per liter. But we do have that we need. We're asked essentially, well, how much of that molar solution would you need to react exactly with the 20 grams? So what we need to do is find out, well, how many moles do we have of sodium hydroxide given 20 grams of a solid to start with? So we have a molar mass. We're going to use that formula. Molar mass is equal to grams per mole. And again, we'll always be able to determine molar mass because you will have a periodic table with you. So our molar mass of sodium hydroxide, we add up the molar mass of sodium, oxygen, and hydrogen, and we get a total of 39.997, which is equal to 20 grams over an unknown amount of moles. So to isolate for moles, we're basically swapping our molar mass and moles. So we have moles is equal to 20 grams divided by 39.997, and we get a final answer of approximately 0.5 moles, which should make sense to us because if we're saying that the molar mass of sodium hydroxide is almost 40, it's 39.997, that's telling us that for 40 grams of sodium hydroxide, that's 1 mole. So we have about half of that. We're given 20 grams of sodium hydroxide. So it makes sense that we are now half of a mole. So just make sure as you're doing calculations that you're kind of, checking your answers along those type of questions, because in chemistry we never lose things along the way. That's the law of conservation of matter. So these type of answers should start making sense to us. So we're given that we have 6 moles over 1 liter of hydrochloric acid, and we need to have some amount of that equal or react exactly with 0.5 moles. So we have a 6 molar solution, and we're basically needing to go down to just a 0.5. So there are 2 different approaches over an unknown amount of liters here. So you can go ahead and plug in your M1V1 calculation here, or you can do it this approach. So like this is basically a math calculation, and so there's always one way to do a math question. So what I'm going to do is I'm going to basically cross multiply, because I have a fraction equaling a fraction, and I want to know how much out of that 6 molarity from hydrochloric acid I need to exactly react with that 20 grams. So I have 6 moles multiplied by our unknown amount of liters is equal to 0.5 moles multiplied by liters, because 0.5 multiplied by 1 will still give us that 1 liter. So X is actually going to be 0.5 moles multiplied by liters all over 6 moles. And so this is important because the moles cancel out in this calculation, and then we're left with our volume equivalent, which is what the question is asking us. Now, right now our formula is in liters, but we can easily change that to be milliliters after we figure this out. So 0.5 divided by 6 actually gives us 0.08 liters. So we're going to multiply that by 1,000 to get it into its milliliter equivalent. So from our 6 molar hydrochloric acid solution, we need about 83.3 milliliters of that solution to react exactly with 20 grams of sodium hydroxide brought up into a liter with distilled water in order for that 20 grams to completely disassociate and to form sodium chloride, otherwise known as salt, and water.